Now at present, I have decided to speak on properties of skeletal muscle. Properties of skeletal muscle, just briefly if we talk on different properties of skeletal muscle, then the first should be excitability, then contractility, then refractory period, then tonicity, then conductivity, extensibility, and elasticity. अगर मैं फिर से कहूँ कि इसकी धर्म क्या है, स्केलेटल मसल की प्रॉपर्टीज मीन्स excitability. If we stimulate, it can be excited. So stimulation के पीछे there will be a response. If we provide a stimulus, there will be a response. Excitability. Contractility. Response means there will be a contraction followed by relaxation. Then refractory period. It has different refractory period. One is absolute refractory period, and another is relative refractory period. Then tonicity. If we stimulate the muscle, it can show the different type of tone. So tonicity is there, and that tonicity depends upon the formation of cross bridge. Then conductivity. If we stimulate one point, then the electrical events can be there, and these electrical events are propagated. Conductivity. Then extensibility and elasticity. Extensibility means if we stretch the muscle, then this muscle will be responded against a stretch, and again elasticity. If you look at the any elastic rubber आप देखे होंगे, तो आप if you put a stretch, then this can be elongated, and then again it will come back to its normal length. तो सेम चीज़ यहाँ पे भी आपको दिखेगी. अगर आप स्केलेटल मसल को थोड़ा स्ट्रेच करेंगे, बढ़ता तो है लेकिन फिर से वो अपनी जगह पे वापस आ जाती है. So these are the properties. If we again talk in details about excitability, contractility, refractory period, we can see all these properties while sitting in the lab. हम लैब में बैठ के ये सब प्रॉपर्टी हम स्टडी कर सकते हैं. कैसे? What type of experimental design we must have? Talking about the experimental design, we have a stand, and then we have a board where this is the stand, and this stand is attached to a board, and on this board we have the gastrocnemius muscle. This is the gastrocnemius muscle, and this is the sciatic nerve. This is the muscle, gastrocnemius muscle, and this muscle can be fixed with the help of alpine. Alpine तो आप जानते हैं. This board is made such a way this alpine can go inside. So this one part of the muscle is fixed, and another part is connected to a lever. Another part is connected to a lever. Now if we stimulate this, if we stimulate this with the help of a stimulator. So suppose this is the stimulator. This is a stimulator, and this stimulator can have output, that is we have the electrode. This electrode, the electrode here, one is positive electrode and another is negative electrode. So with the help of this electrode, one is positive and another is negative, we can stimulate this muscle with the help of stimulator. And this is the drum. We have the kymograph. This is the drum. This drum, with the help of this drum, this is the kymograph. If you ask your teacher, he or she will explain, will tell you, or will give you one machine, kymograph. It's a small machine, and this drum can be rotating. This drum you can see here, this can be rotating, speed 640 millimeter per second. If you put this, if you fix with this speed, then drum will be rotating. Now what will happen? If you stimulate, provide a threshold stimulus, then you can record mechanical event of the muscle. What type of mechanical event? You are providing the stimulus here, threshold stimulus. So action potential is generated here, and this action potential ultimately it will reach here, action potential, and there will be a contraction. So as we all know, when skeletal muscle is contracting, then the length is reduced. Length will be reduced. One side is fixed, all-pin is there. This one side is fixed with the help of all-pin. Another side, this will move towards this. So once it is moved towards this, then this stylus will go up. And then at the time of relaxation, again the length will come back to its normal position. Means this is the point of stimulus. This is the point of stimulus. This is the point of stimulus. This is the point of contraction. This is the point of contraction. This is the point of maximum height of contraction. Point of maximum height of contraction. And this is the relaxation period, contraction period, and this is latent period. So three period I have mentioned. Again, if I draw it nicely, see the graph we can get. One is latent period, one is contraction period, and another is relaxation period. And this is the height of maximum height of contraction. This is the maximum height of contraction. Maximum height of contraction. So again, if I repeat what I have told you, that properties of the skeletal muscle can be studied while sitting in lab. If we have living tissue, what living tissue? We know मेंढक आप जानते होंगे. तो फ्रॉग में living tissue मिल सकता है फ्रॉग से. This is the gastrocnemius muscle, this is the sciatic nerve, and this is the piece of spinal cord. This living tissue can be isolated quickly from the frog, just after pithing and stunning. After stunning and pithing, we can collect this muscle, as well as this muscle is controlled by the sciatic nerve, and again the sciatic nerve is regulated by the spinal cord. So this preparation is called gastrocnemius sciatic nerve muscle preparation. So this preparation is utilized to show the properties of skeletal muscle. The first properties I have told you, the excitability and contractility. So this property, if we want to study in the lab, then we will have to record the simple muscle twitch. So this graph, this is the mechanical event of skeletal muscle. It is called simple muscle twitch. This is called simple muscle twitch. This is the mechanical event. What are the periods we have here? One is latent period, that is the period between point of stimulus and the point of initiation of contraction, and then contraction period. It is the point of initiation of contraction up to point of maximum height of contraction, and then relaxation period. This relaxation period is actually from the point of maximum height of contraction up to the end point of relaxation period. So that is the relaxation period, this is contraction period, and this is latent period. So these periods duration we can calculate. Normally the duration is 10 milliseconds. Normally the duration is 10 milliseconds. This is 1 millisecond, this is 4 milliseconds, and this is 5 milliseconds. So total duration is 10 milliseconds. We can calculate. How we can calculate? If we know the drum speed, if we know the paper speed, that is 640 millimeter per second. If we know this, we can calculate the duration of latent period. Just we will have to measure the millimeter distance, and then if we apply this 640 millimeter is moved in 1 second, then this much millimeter is moved in how much second. So that we can calculate easily. Latent period, contraction period also we can calculate. Just length, from this to this length we will have to determine, and this length will come in millimeter, and from this to this also we can determine easily millimeter. So accordingly we can calculate the duration of latent period, contraction period, and relaxation period, and this whole is total period, and this total period I have told you this is 10 milliseconds. That is the excitability and contractility. If we want to study in the lab, excitability and contractility can be studied. Living tissue should have been there, and then proper amphibian ringer should be used. Then we'll have to provide threshold stimulus. In this threshold stimulus, if we provide, then easily we can record simple muscle twitch. Means just once we can record the contraction followed by relaxation. In this simple muscle twitch, we have 3 periods. One is latent period, then contraction period, and then relaxation period. Now excitability again, if we can study by using the different temperature. Sometimes we can use hot amphibian ringer, and sometimes we can use cold amphibian ringer. So if you use hot ringer, then what type of record will be there? In case of hot, this record will be there. So what changes we can have if we apply the hot ringer? Just 2-3 minutes you have to change the temperature of this muscle. Here you have to keep adding the hot amphibian ringer, nothing else, only hot amphibian ringer. So what type of record we will have? In this record, if we see, total period will remain almost same, but what changes we will have? There is a change with the height of contraction. Change with the height of contraction, and this height comes, see, मसल जो मसल मैंने पहले यूज किया वही मसल है, वही नर्व है. Place of stimulation also same. What we have used? Just hot ringer. If we use the hot ringer, then we can see the better height of contraction. Height of contraction will be increased. Means in this case there will be a more and more number of cross bridge. Means here if there is an involvement of 50 cross bridge, just I am giving one example. In this case there may be an involvement of 90 cross bridges. Means if we can increase the number of cross bridge formation, tone can be increased, and also the height of the contraction also can be increased. Just simply by altering the temperature of the medium. Just if we can change the temperature of the muscle, we can see this change. Then if we change the again, if we apply the cold ringer, instead of hot, if we apply the cold ringer, then what will happen? This same record will be like this. What changes we are having? The total period is increased. Total period. So this is the total period. This total period is increased, and height of contraction is reduced. Height of contraction is reduced. Means what I want to say is, if we change the temperature of the medium, if we bring it, if we can alter and keep adding the cold ringer, then what will happen? Contraction will be there, but the process will be slow. So means what I want to say is, the temperature can change is a big factor. It can change the excitability, it can change the contractility, it can change the type of contraction, whether it will be weak contraction or it will be a strong contraction. So that contraction comes by altering the temperature of the muscle. Another way we can look on excitability and contractility. Another way we can look on excitability and contractility. Just I am drawing this again. Now what I will do is, if in this is the drum, again I am drawing this, this is the kymograph. You can see the kymograph is looking like this, and this is the pointer, Now what we will do, instead of hot or cold, what we can do is, same preparation is there, just we will change the strength of stimulus. If we have provided 5 volt, now in this we will have to change the strength of stimulus. 5 volt we can provide, then we can have simple muscle twitch by applying 10 volt. Then same muscle preparation is there, we can provide 15 volt. What we are doing? Just we are changing the strength of stimulus. Very simple. Here we have the switch. Just by changing the position of the switch, this is the stimulator. So by changing the position of the switch, we can adjust the strength of stimulus. So just if we can adjust the strength, if we can alter the strength, पहले हमें simple muscle twitch लेना है. पहले 5 volt का record. This is the record. By using the 5 volt, then we can have the record. Using the 10 volt. Then we can have the record using the 15 volt. Then again, if you increase 20 volt, you will have the same height of contraction. So this is 5 volt, this is 10 volt, this is 20 volt, again 25 volt, again 30 volt, again 35 volt. Try to understand what I am talking about. At first instances, if we change the strength of stimulus, पहले 1, 2, 3 बार, there will be a response. Means we will have gradual increase with the height of contraction. Height of contraction can be increased by altering the strength of stimulus. उसके बाद क्या होगा? Time will come. We are increasing the strength of stimulus, but the height is not being changed. Means muscle will have a capacity to respond up to a certain limit. उसके बाद आप कितने भी बढ़ा दो स्ट्रेंथ ऑफ स्टिमुलस, उसकी हाइट ऑफ कॉन्ट्रैक्शन चेंज नहीं होगा. क्यों? अगर इस मसल में मान लीजिए कैपेसिटी इज 100 क्रॉस ब्रिज फॉर्मेशन, मान लो मैं एग्जांपल दे रहा हूँ, इस मसल में 100 क्रॉस ब्रिज बन सकती है. तो जब 5 वोल्ट हमने दिया है, मान लीजिए एट दैट टाइम देयर इज ए इन्वॉल्वमेंट ऑफ 20 क्रॉस ब्रिजेस. उसके बाद जब 10 वोल्ट हमने दे दिया है, मे बी देयर इज एन इन्वॉल्वमेंट ऑफ 50 क्रॉस ब्रिजेस. व्हेन वी हैव प्रोवाइडेड 15 millivolt, 5, 10, 15 millivolt, then maybe there will be an involvement of 90 cross bridges. Capacity is 100 cross bridges. This muscle has a capacity to have 100 cross bridges. So that 100 cross bridge already is going to be over by applying 20 volt. उसके बाद आप कितने भी आप इसकी वोल्ट आप चेंज करते रहिए, लेकिन हाइट ऑफ कंट्रैक्शन विल रिमेन सेम. In this experiment, what I am saying is, muscle has a capacity to respond, capacity to give the response against a certain strength of stimulus. Means up to a limit, there is a limit. Up to a certain point, there will be a response. After that, if you keep increasing the strength of stimulus, there will be no change with the height of contraction. So this curve, actually, this experiment is known as effect of varying strength of stimuli. Effect of, earlier it was effect of temperature on simple muscle twitch. Here effect of varying strength of stimuli on simple muscle twitch. Now coming to the contractility also we have tested by using different temperature of amphibian ringer solution, or by applying the strength of stimulus also. By applying different strength of stimulus also, we can change the contractility, excitability, conductivity, contractility, that can be tested. Now coming to the refractory period. Refractory period also can be tested very nicely. Just look at this. What is refractory period? That we must look. This is the action potential recorded in skeletal muscle, 1, 2, 3, and this is plus 40 millivolt, and this is the minus 70 millivolt. I am talking about refractory period. Refractory period is two types. One is first 2/3 is absolute refractory period, and last 1/3 is relative refractory period. Now try to understand what I am saying is, ये जो absolute refractory period है, in this period if we provide second stimulus, whatever the strength may be, चाहे 5 वोल्ट की जगह 50 वोल्ट भी भेज दो, whatever strength may be, the muscle will not respond. Means there will be no contraction relaxation. What I have said, if we provide second stimulus, in which period? Absolute refractory period, then this muscle will not respond. But if we provide better strength of stimulus, and that should be more than the earlier one, then in this relative refractory period we can see the response. Nicely we can perform this experiment. Say this is the kymograph, and this kymograph, here we have a pointer here. and this pointer can be extended. दो जो मैंने बना लिया है, इसको जस्ट आप प्रेस करेंगे तो ये दो हो जाती है. Now what will happen? By adjusting the distance between two, we can provide second stimulus. During absolute refractory period. We can provide second stimulus in relative refractory period. Very simple. Nothing is difficult. Easily we can perform. Just this switch is there. This pointer is there. Just you have to adjust such a way so that the second stimulus can be delivered. It is rotating. So circuit will be completed as soon as this point is touching and this point is touching. So there will be 2 points we are creating. First point, that is the first point. We will have the electrical response, electrical events. And second point, we'll have to open such a way. We'll have to fix this knob such a way so that the second stimulus can be delivered in absolute refractory period, or the second stimulus can be delivered in relative refractory period or after relative refractory period. Then what type of record we will have? See the graph here. What type of record we will have? What type of record we will have? Here, this is the simple muscle twitch. That already I have shown you how to record simple muscle twitch. Now, after recording simple muscle twitch, we will have to open this. Then what will happen? If we can open this, then what type of graph we will have, that I will show you. Just see here. We will have either this one, or we will have, see here the graph. I think it is not easily understood. Again I am removing this. What I am saying is, if we make this distance, and then if we make this distance, then suppose this is the simple muscle twitch without opening this. Now after opening this, we may record the similar one. Similar height. There is no change in the height. Now again, if we open more, if we increase the distance between two, then see, this is one simple muscle twitch and another simple muscle twitch, but the height is better than the first. That is actually the name of the experiment is effect of two successive stimuli on simple muscle twitch. Two successive stimuli. This is one stimulus, this is another stimulus. Two successive stimuli. This is the response coming from one stimulus, and this is the response coming from another stimulus. But how you can explain that height is better than this? ये height कैसे बढ़ गया? इसमें height इसीलिए बढ़ गया है. Just if we look back to our mechanism of skeletal muscle contraction, where calcium ion is vital, calcium ion is very much essential. After stimulating this, in that medium calcium ion is there. So all calcium ions are not sent back. Calcium ions are there. Then again there is a second stimulus. So because of the second stimulus, again some amount of calcium ion are added in that medium, and jointly all calcium ions are acted such a way, so there will be a more number of cross bridge formation. So that is the beneficial effect also we can show. That is effect of two successive stimuli. Actually aim is to deliver the second stimulus during relative refractory period or after relative refractory period. So if we can do this, we will have better height of contraction. We can record two simple muscle twitch, but the height of second twitch will be better than the first. So this experiment also nicely we can perform in the lab. Then the other properties is tonicity. Tonicity also can be explained from this experiment. Tonicity. In this height, I think if we compare the tone, here the tone will be better than this. And tone depends upon how many cross bridges are being formed. So here, if capacity of formation of cross bridge 100, then we can see there will be a formation of 100 cross bridges. But in this case, there will be a formation of 40 cross bridges or 50 cross bridges. So the tone here is better than this. And if we want to prove the tonicity, then this can be one experiment. Another experiment to study the tone of the muscle, that is genesis of tetanus. Genesis of tetanus, if we want to study, then this is the, see, this is one cycle per second. This is 10 per second. This is 20 per second. Say it is 50 per second. Means duration is fixed, but the number of stimuli is increased here. Duration is fixed, 1 second, but the number of stimuli is increased. So if we keep increasing the number of stimuli, then there will be no complete relaxation. There will be no relaxation. So failure to relax, not failure to relax. I am taking my word back. Sustained contraction, that is the sustained contraction we can see. Sustained contraction, that is the genesis of tetanus. Means as we keep increasing, see, height of contraction is increased here. Means gradually tone of the muscle is increased here. And this tone is increased because of increasing the frequency. Here 25 per second, here 50 per second. So if we keep increasing the strength of stimuli, not strength, the frequency if we increase, then we have this type of effect. We call it, the name of experiment is genesis of tetanus. Now another is conductivity. Conductivity we are stimulating here and we are having the response, that is the conductivity. The electrical event is generated here, action potential, and ultimately there is a contraction and relaxation. So from this also we can say that conduction is there, and that is why we are having contraction and relaxation. Then extensibility and elasticity. Extensibility and elasticity, very nicely we can do this. The experiment is, for this experiment is effect of preload and afterload. Effect of preload and afterload on simple muscle twitch. What I have said, effect of preload and afterload on simple muscle twitch. Preload and afterload on simple muscle twitch. Coming to the effect of preload and afterload. Now look at this apparatus, please. Here, this lever is having a screw here. Look at this. This is the screw. This screw is there. And here we have this is the pointer. Here we have holes. Holes are there where we can apply the load. Try to understand. This is the lever, and in this lever we have holes are here. With the help of hole, we can use the load. So this load can be 5 gram or this load can be 10 gram. Now try to understand, if this screw is touching this, then this lever is not free from the load. But if it is free from this, then we can say we can say load is applied to the muscle before contraction. So in this experiment, again if you look at, here screw is there. This screw is called after loaded screw. This screw is called after loaded screw. This screw is called after loaded screw. This screw is free from the lever. अगर ये फ्री है, लीवर से फ्री है, तो जितना भी आप लोड यूज करोगे उससे क्या होगा, ये मसल की लेंथ जो है बढ़ेगा बिफोर कॉन्ट्रैक्शन। आवर एम इज टू चेंज द लेंथ ऑफ द मसल बिफोर इट कॉन्ट्रैक्ट्स। सो फॉर दैट वी कैन यूज टू टाइप ऑफ प्रिपरेशन। In one preparation, this screw is free from the lever. So in this case, whatever the load is applied, this load indirectly is transformed to the muscle, is connected to the muscle. So the length of the muscle, there is a possibility to increase the length of the muscle before it contracts. And if this screw is touched here, then कितने भी आप लोड यूज करो, there will be no change with the length of the muscle before it contracts. Before contraction, there will be no change with the muscle if you use this screw here, if it is touching this. Now, what type of record we will have? See, what type of record we will have? This is the contraction. This is the contraction. This is the contraction when there is after loaded screw. आफ्टर लोडेड स्क्रू इसको टच करके रखा है और वेट कितना है, से इट इज 5 ग्राम. सो दिस इज द हाइट ऑफ द कॉन्ट्रैक्शन. नाउ इफ वी इंक्रीज, if we make it free from the this, then what will happen? This type of effect will be there. Why? Because in this preparation, this load, this screw is free from the pointer. So that is why this load can stretch this muscle. Stretching से क्या होता है? There is a possibility to increase the number of cross bridge formation. तो अगर क्रॉस ब्रिज फॉर्मेशन ज्यादा हो गई तो हाइट ऑफ कंट्रैक्शन ज्यादा होगा. और यहाँ पे जो है ये पॉसिबिलिटी नहीं है, क्योंकि ये स्क्रू जो है इसको टच करके रखा हुआ है. दिस स्क्रू इज टचिंग द लिवर. सो कितने भी आप लोड यूज करिएगा, there will be no change with the length of the muscle before it contracts. So that is why this is the height of contraction when the screw is touching this, and this is the height of contraction when this screw is free from this. So that is the experiment effect when it is free load, and this experiment when it is after load. So what information we are getting here? Here we are talking about extensibility and elasticity. See, this muscle can be extended by using the load, that is free load. This muscle cannot be extended when it is after load. So if we can stretch the muscle before it contracts, we will have better height of contraction. So extensibility and elasticity can be proved by using this experimental setup. Easily we can perform this experiment in the lab. So these are the properties of skeletal muscle which you must do in the laboratory. Easily you can perform if you have living frog, and then if you have stimulator and kymograph. Simply we can do all these experiments. Thank you.